This should be a fun panel. This is one of those things where each of these panelists could profitably teach you and interest you for a full hour each, and we're going to give you a speed through this issue, and hopefully we'll build upon what you engaged on yesterday in the panel. I'm going to shorten my overview so we can get to it. So here's what we're going to do. We're going to look at, I'll give a brief introduction, then we'll go over the panel, then they'll do the presentations, and we're going to try and get to time for questions and discussion. But I put these pictures up because people have an interesting relationship with the concept of AI. Some know it well, some have dug into everything there is, some are already worried about their kids trying to do all their papers on ChatGPT and getting caught. People are doing really hilarious birthday poems. I think that's one that most of us understand. And I think one of the images that come to mind is out of a brain, and that gets to the part of the discussion about what's the difference between just using data and using artificial intelligence, because it has to do with kind of a self-learning capacity of the system as well as the incredible volume of material that can be held. There's also an issue where people, and it was interesting Googling artificial intelligence, so many of the images that come up are about robots and scary robots. And if you're me, you always go straight to Skynet. Like, how many of you asked Alexa or Siri if they knew Skynet? How many of you asked? Oh, you guys are just not creative. Of course you did. At any event, so it's scary, but it's really not about robots so much, and yet that's the image that comes to mind that scares people. But by the same token, it really is a game changer. It's not a potential game changer, but it's a game changer that's coming whether you're ready or not. So this is one of those things that people think they're going to put off for a while. It's too hard, it's too expensive, we don't have the people, all the things that you've seen in the surveys, but it's a game changer whether you're ready or not, and you have a choice about how you look at it. It shouldn't be the scary robot or Skynet, it should be something else. It has the potential in far more cost-effective and better management of water resources of all kinds, just because of that ability, not just to be able to amass a lot of data looking backwards, but to be able to do really advanced predictive analytics and that sort of thing, saving money even on leak detection and repair, all those things that you've seen in any of the panels you've been at in technology, so that we can take that technological evolution of sensors and make it work for us. I mean, it's sort of incredible. So it is going to also have an impact on policies of all kinds, and we're going to try and focus on that in this panel, in addition to just the management of facilities and systems. But it's going to require a lot of effort and some thought. Better data, the right people, the right questions, and we have the panel for you to help explore that. Now, as I said, data and technology are making a world of difference, and AI is more than just an accelerant. It has those policy implications at scale, really is a game changer. So I gave you the friendliest game changer picture that I could ever think of. Aren't you all happy now, just looking at that sweet face, that sweet murderer of a basketball player who's changed the game completely? Or this idea, this was the best image I could find, which is AI is a tool that we hold in our hands. And I think Frank and others are going to talk about AI isn't AI taking over our systems. The integration of the human factor, your leadership and management is absolutely essential to this working. And fortunately, hopefully, maybe there's a downside. In the water management world where we're thinking about this, it's pretty much all upside. If you think about it at home, at night, watching the TV, thinking about the world we live in, there are plenty of things to be afraid of with AI, whether in education, others, and fake news, and all the stuff you might think of. But in our world, you can see there are all kinds of opportunities to make to the synergy between technologies, human and others really work well for us. Okay, with that, I'm just going to move straight to our panel. Again, look online. There's a lot more to say about them. Jim Cooper, the Director of Intelligent Water Management for Arcadis. I used to think I was trying to be the the Director of Intelligent Water Management in many of the jobs I've held over my life, but you actually have the title, and so you have the obligation now to be the most intelligent water manager in the room. I'm just saying. Frank Urey, the President of Santa Margarita Water District Board, and many other things that you will see, and Erik Ekdahl, Deputy Director for Water Rights at the State Water Resources Control Board. And I will acknowledge that we need to change the names, because it sounds like he's the deputy to the Director of Water Rights, but he's the Director of Water Rights. He's just a deputy director within the institution, so we have to think about that. So we're gonna, sorry, just always working on things. Any event, so Jim's gonna start with his broad overall experience in many places in this work. Frank's gonna follow as a local agency leader, and I will say, I hope you take this as a compliment, a water geek. That's an honor coming from me. And Erik's going to follow up with how it's playing out in the policy arena at the state level. And then after the prep call, I just have to say you're going to enjoy your time with these folks. So with that, no further ado, they're going to come up. We're going to try and give them, we've shortened our time to talk so that we have some time for your questions. And with no further ado, take it away.
Excellent. Thank you, everyone. Good morning. So if I ask good morning to an AI or any electronic device, it would give me a response. So wait a second, who's better here, AI or humans already, right? I haven't even started. Good morning. There we go, okay. So I'm gonna talk a little bit about policy in the age of AI, a little bit of background in this topic, and actually one of the focuses on my current research I've been working on is the laws and ethics around AI. So for the next 3 hours, I'm going to talk a little bit about that research, and we'll go from there. So I'm going to start out with the definition. Everyone has their definition. I like to talk about this just so when I talk about AI, you know my perspective of what I'm talking about. I think of AI as the ability to sense, reason, engage, and learn in a manner that seems intelligent. I think if you don't have one of those components, you don't necessarily have AI. So there's a lot of people out there that have a nice machine learning algorithm, and they say that's AI, right? I can understand that perspective. I kind of think of that as going and buying 4 brand new tires and then saying I bought a brand new car, right? It's one component of it, certainly not the whole thing to have AI. This is about intelligent questions. So we talk about artificial intelligence, but we don't really talk about artificial stupidity. So how do we guard against mistakes? Right? Felicia already said AI is a tool, not the solution. But we seem to think, as humans, not just the water sector, as humans, that when you have AI, it is 100% right. If it's 99% right, then AI is garbage, right? If we're setting ourselves up thinking about that, it's going to fail 100% of the time. So we need to understand, when is AI not the right application, or when do you have a result that might be optimized but stupid, right, and not something that we would actually implement. And start thinking about that. Well, then there's the human component of this. You have a human in the loop as a part of your process, and we'll get to kind of the concluding slides I'm going to talk about, which isn't AI, but certainly around the same topic. So a bit of audience participation. I started to see if you're all awake. It took a little bit. Depending on what you consider a computer, right, there's about 3 billion computers in the world today. What is their primary purpose? Dating sites. You're not entirely wrong. Oh, your phone, okay. Any other ideas? Measuring. Okay. You are wrong. It is people communicating with people. On dating sites, on Facebook, on your email, on typing a Word document, computers are primarily used for us to communicate with other people. They're not primarily used for computing or for AI or for doing basic math. So think about that in the context of, if we truly want to implement and use AI within the water sector, how are humans involved in that? They have to be involved in that. They're critical to it. It's not AI going to take over the world and it's all robots, right? Again, think about this in the context of policy and laws, and we'll get to that here in a bit. So why are we not using AI any more at water utilities than we are today? Any thoughts? fear. Any other thoughts? Risk? Lack of infrastructure, culture. Yeah, that's a very interesting one, right? It's interesting that we're here talking about AI and not talking about what AI can do for us, right? It's really interesting that, if I was going out there and trying to sell an iPhone today, I wouldn't be saying, this is full of AI. I would go on my Photos app and type a picture of, or type in people, and pictures of people would come up, right? It's showing what it does. It's not talking about AI. In the water sector, we're not quite there yet, in my opinion. We're talking about the tool, not talking about the solutions it can do for us and the value we can get from that. So a lot of good thoughts there. There is some research out there on what are the barriers. This is specific to applying AI to the water sector. It came out this year. People, right? Personnel, skills, number one. And then uncertainty on ROI is number two, right? How long is the payback? Is it worth it? Is the cost there? Right? Certainly a lot more to talk about and unpack on that, but I don't have that much time, so I'm going to keep moving on. So machine learning. Just a quick sidebar. It's one of the components, in my opinion, of AI. We have this perception of this is what machine learning is. In reality, machine learning couldn't be more simple. It couldn't be so far away from a black box that we think it is. We take data, we apply some sort of calculation, and we get an outcome from that calculation. We look at that outcome and say, did that match? If it was a forecast, was it good or not? And we improve our calculation, and we repeat that with fresh data. That's machine learning. It's, in my opinion, literally that simple, right? But we seem to think that this is machine learning. So we think of this massive black box, we put it on a pedestal that it can do everything, when in reality, you could potentially, if you have the right setup, do machine learning in Excel, right? Now today, our algorithms, that decision process calculations, are more and more and more advanced than they ever been, right? We have many different algorithms we can use. That's typically what we think about when we think about machine learning is the complexities, the type of algorithms. The interesting component here is when we think about data, we've talked a lot about data. I think almost every person, if I would ask them what is data, practically grounded, they would say a database, Excel, numbers, letters. We're really not even thinking about data as noise feeds, thermal imaging, vibration, right? All the stuff that's not letters and numbers in the database, but where we can truly leverage the power of some of the machine learning tools, right? So simple. If you have a pump station, put in a camera there that's a thermal image camera, put in a noise monitor, and apply a machine learning algorithm, right? Computer vision, some signal detection to identify when you have a bearing that needs maintenance on it, right? So simple, but we're not thinking about data in that way. So this is a report, Demystifying Intelligent Water, free report. You can download it if you want to on the QR code. This came out 4 years ago, and it was a collaboration with Bluefield Research. And I like this graph as one of the graphs that came out from that report and said, AI, right, where is it? What's the forecasted growth of it? And we're, I think, pretty well online with where we were saying 4 years ago. I don't think we're any big surprises today of where we are with AI in the water sector. So let me explain a little bit more, and then I need to wrap up here. My first, not pilot, but full-blown AI project with the water utility was 10 years ago, 2013. So I actually first created this slide here in 2015, so that's why you see 2015. Right? At the time, we're all in artificial narrow intelligence, which is really isolated project-specific examples. You don't take the same AI that's going to tell you which pipe is going to fail next and tell you how to optimize your chemical process. Different components, right? Moving towards artificial general intelligence at a certain time. I think we've seen a huge leap in that with the generative models we've been talking about. And interesting observation, and we've talked about this some over the past day and a half, is that something like ChatGPT, with the flip of a switch, all of a sudden, in my mind, made us realize that humans are the weak link. And it's almost scary, and if I talked about that 2 years ago, people would be laughing. But all of a sudden, the limitation of using something like ChatGPT is our ability to ask it questions, right? That's kind of scary to think about where we are today. and of course, at some point in the future, artificial superintelligence. I talked about AI. At Arcadis, and a lot of the work I do, we focus on CI, or collective intelligence. That's the abilities of humans and machines to collectively present far greater intelligence than they could on their own. Bringing that all together, human in the loop is a key component. When we talk about ethics, when we talk about laws, one of my very interesting and passions is how does AI impact operator certification? How is an operator, at what point are they using AI as a tool? Or at what point does the computer need to be a certified operator and have the risk of public health for that system? There's kind of a fine line there. Quick question. Anyone have any idea how many states currently have an AI law within the state legislature? Any guesses? I hear zeros. 23 states have laws about AI today, right? Really interesting. How many of them are about the water sector? It kind of gets into the details, right? And when we get into the panel, I'll talk more about what some other countries are doing, and there's actually quite a bit of work around the laws and ethics of AI that are being applied. Even here in California, there are, I think, 4 or 5 active pending legislations around high-risk AI, which is where the water sector technically fits within a range of AI that's active going right now. So does policy matter? I'm going to end here. 2 different utilities, the top one and the bottom one. So the top utility, they embrace status quo. They generally deprioritize digital, right? That's going to come, when they retire. They have some recruitment and retention challenges. They sometimes lack process improvement funding and are really having declining customer confidence. Not a dystopia, a very real example of many utilities. Bottom, a different one, only slightly different. The utility leaders recognize there's this true dawning of a new era around digital. They're sort of fostering that digital discussion. They're not jumping up and down saying use AI, but they're saying, hey, we should look at this and think about it. They're actually improving recruitment because the new incoming talent are seeing that there's some interesting things that utility is doing for technology. They're recognizing education needed within their workforce, and they're changing status quo. Does policy matter? Absolutely, right? Which one policy is going to direct which one you go, if you're a utility or if you're a water board or any direction around there. With that, thank you, and I'll turn it over to Frank, our next presenter.
Thank you very much. I got to tell you, after listening to that, I find myself fixated on Jim's second slide talking about artificial stupidity. And I'm sitting here going, all right, I'm a politician, and who's he referring to? Because the fact, so I'm sitting down there, I listened to his question, how many states have laws on AI? And he said 23. As an engineer, it scares the daylights out of me, because part of the challenge that we have, especially within technology, is we having non-technical people writing technical legislation on stuff they do not understand. And when I tried to tell my wife we need more electrical engineers and engineers in general in politics, she hits me. So, but we do need more people running with it, because there's such a transformation going on right now. And I'll give you the one example. I was listening to a speech years ago, prominent politician, and national politician. And he said, look, the studies show that if you go to an ATM machine and the transaction doesn't start within 20 seconds, you walk away because you get frustrated. On the flip side, it takes 6 to 9 months for you to get your medical bill. And his point was, in our society, those will not always be allowed to coexist. And that's exactly where we are with AI. The rise of AI as a public policy item, it is an inevitability. It is coming. And I say that not as a sombering note, but more as an effort to foster dialogue, because we need to have the open discussions with senior management and the comfort of our employees to come to us with ideas, and then external folks to help put all that stuff together. If we don't get in front of this, we will get run over. 25 years ago, that was the web and everybody getting on the internet and having their websites, and some were early adopters and some were late and some got run over. 12 years ago was cybersecurity. The agencies that got in front of cybersecurity, they had the policies, they're usually more resilient. The late followers were the ones who were more at risk. It's going to be an identical transformation for AI. The folks, and I say folks, the agencies that get in front of this and start making it part of their policies that they're working on will do fine. The ones who aren't, they will be laggards, they will fall behind, and they will most likely really disappoint their constituents. And kind of to the point, it needs to be embraced. This is part of what we do. It's part of why we get into water, be it as an elected official or policy people. So just real quickly, I know I got a short amount of time. This is not a comprehensive list, but there are a lot of things that are prerequisites. And it's interesting because I know there's discussions about AMI and data and technology. We are getting to the bifurcation point where if you do not have the data collection, if you do not have the AMI systems in place, if you do not have the data warehouses, you will be left behind. You will be the ones out there in a few years still with individuals walking and reading meters, and your constituents are finding out that they have a leak 3 weeks after or 3 months after it happened, whereas the next neighboring agency, when there's a leak, somebody will let them know within 20 minutes. Those are our two worlds. One's going to succeed, the other one is not. So from a policy standpoint, data cleanup and getting that data standardization, every agency needs to do it. This is not a chance for you to say you don't need a physical anymore. You have to go in and make an effort to clean up the data. Where it gets interesting for the policy people is the transparency component. I think this is the biggest issue that we're not addressing. We do not know, because as an elected official, I am subject to the open meeting laws. I'm subject to PRAs. I'm subject to the Brown Act. How do we handle PRAs and requests for information and data, and how does that affect the data that we have that we control? Now, I'm a big fan of making sure the data is exportable and shareable and people can get to it. But think of if you had an employee that decided they were going to run it to ChatGPT and they were going to run some report on the data set internal to find out the worst offenders who did X, Y, and Z with sewage and everything, and they came up with a report. And that report was pretty embarrassing for people, really didn't want to get out there, and then somebody PRAs the report. These are the policies we need to get in touch with because we need to be able to tell our employees and give them the safety, and this is the important part. We need to give them the safety to understand that it's okay to do these things, but do it within the confines of what we're working on. We need to set policies that will govern data and the data you integrate with your strategies. I think that where the next step will go within a couple years, we'll be talking about how we as water managers will be looking to data much more outside of our domains within our water agencies. Everything from weather data to outfalls to watersheds, and how we'll change the operation from a predictive analytics standpoint. If you're at the end of an outfall and you do wastewater cleanup, how you will change your operations based on something that happens 5 days before it gets there. And I think that's the predictive analytics part can be very interesting. It's also very important to understand that these systems have biases, and you said it, keep humans in the loop. I've played with ChatGPT a lot. There are questions I can answer it, or I can ask it, it will answer fine, and I'll ask a different question, it says, I am not allowed. And I don't even want to get into which social issue was, but I said, how has this impacted this? I get a nice report, it's great, story about a person. How has this hurt this? I cannot write on that. There are implicit biases in there. You need to pull that out and make sure you understand it, especially if you're going to get into an equity discussion, because those implicit biases can go there. And as I mentioned, always keep humans in the loop. The tech, if we do this right, what we do is we let the technology do what's basically the technical janitor work. And we work as leaders to train our employees up so that they do higher, much more enjoyable functions. I also think it's very important to get the community engaged. Let them know where let them know where you're going with this and keep them informed of the strategy. I always tell my colleagues the challenge that we have is that most of the people leading water agencies are a little bit later in career. And that includes the people that are elected officials are a bit more later in career. We have a difficult time talking to people under 35. We need to figure this out because this is their domain now, that we have to communicate on their level. We also, and I think it's been mentioned a couple times, we need to embrace risk. We need to give our employees the ability to understand that we will do some risk taking. We are, to your slide, we are at the 0.01% level of where we're going to take this. We will try things that will not work. We will do things that will be awesome. Let your employees, let your policy people, let your residents come up with some ideas, and don't be critical of the failures. Embrace them. I always tell my team, if you've learned something from it, great, I'll invest in it. And for public agencies, it's going to be tough. It's going to be very tough for us. As an example, there are 75,000 open cybersecurity jobs in California. Most of those make more, or jobs that will make more than your general managers. You cannot outprice these people in this industry. If you do not embrace public-private partnerships and get in touch with companies that you can deal with, you will be left behind. We cannot do this on our own. It's not, and that's not a bad thing. A couple of the pitfalls, you do need to control what your team does. We haven't talked about it too much, but cyber risk is a big deal, especially as you open up your data sets and open up that stuff. And I'll leave it at the bottom one. The biggest risk is going to be inaction. That's what's really going to kick in the head. This is coming, so get in front of it and lead it. Let's see. Some of the possibilities in there, I'll just go ahead and leave it. I think predictive maintenance is an easy one that we can all get into. Real-time leak detection, once again, you'll have two different agencies. One's going to fail. One project I'm working on right now has to do with ratepayer sentiment, where they're actually harvesting data from petabytes of data to try to get an idea of how public is viewing things. It's going to be great information for elected officials, especially if they're looking to sway some of that. Ratepayer self-service is going to be a big deal. You can talk to these systems and have them answer, and I think one of the bigger ones is going to be language translations. The one I use internally, our internal chat can do 140 languages. I'm Hungarian by nature, actually by lineage, and it translates it perfectly. It's pretty wild stuff. So meeting your constituents on their terms. But the list is just getting started. You do need to bring in data science, and I'll leave with my last one. I've said this for years. Sometimes you need the CEO of Nestle to run Intel. And I've worked for Intel for years. What I try to make that point is we need to cross-pollinate, because if we're in water, we know water, we understand water. Talk to somebody outside it, they will look at your problems, to that question that Lauren asked a while back. They will look at your problems differently than you, and they'll teach you quite a bit on it. So thank you very much for the patience. Yeah, speed dating, like I said. And now we move on to the next one. Right.
Good morning. I think it's still morning. Thanks, everyone. I'm Erik Ekdahl, Deputy Director for the Division of Water Rights at the State Water Resources Control Board. And while I have never asked Alexa if they know Skynet, I did name my internet Wi-Fi system Skynet. So whenever I log in, it's to Skynet. So let's just go right ahead to the next slide. I'll try and go quickly, and again, probably could go into a lot more detail for a lot longer presentation and bore people to tears, but I wanted to start off with, why is this an issue for the Division of Water Rights right now? And we're heavily engaged in developing a new data system. In the last 3 years, the administration and legislature has invested over $100 million in water rights, and that's a tremendous sum. 60 million of it for modernizing our water rights data system, additional funding for developing a telemetry pilot project, trying to get real-time water reporting data, and developing new supply-demand modeling tools so we can look at, whether curtailment's necessary in certain watersheds in certain time periods. The way we kind of received this funding wasn't bringing data and saying, look at this data, this is why we need this funding. It was almost the reverse of that. It was, look at the data we don't have. And what do I mean by that? This is kind of pulled from our existing database. This was a slide that we showed to the legislature in January of this year. And it looks at some water rights reporting. This is reported diversions for just the really big diverters, 5,000 acre feet or more per year in the San Joaquin and Sacramento River. And it's kind of a complicated slide, but you see there's a number of claims, and in 2018 in the San Joaquin River, when it says original, that's what was reported to us, 3.7 million acre feet of diversions in the San Joaquin, 12 million in the Sacramento. But when staff go in and look and actually dig into that detail, those numbers aren't right. They're not anywhere close. And when they clean up the data and kind of say, well, you probably missed a decimal point here, and did you mean gallons or acre feet or vice versa? Those numbers change by quite a bit. And so if we look at the Sacramento River in particular, in 2019, there were 29 million acre feet of water diversions reported. In reality, it was probably closer to 4. So we're off by 86%. And part of the reason we're off by 86% is our data system is so antiquated, outdated, that we don't have even the tools to capture the data that should be reported to us anyway. So how does AI factor into all of this? Part of the modernization outcomes are trying to get to data-driven, timely decisions. Do we know who's diverting when, how that water is being used, and how does that free up water for other potential uses, trades, transfers, drinking water needs, environmental needs? That data accessibility will drive that policy of how we look at those decisions. And how will AI integrate into that is going to kind of govern how we structure this new data system that the state's investing up to $60 million in. Do we build those tools now? Do we plan for this inevitability of this thing that we know is coming? Or do we look back, which, not to put the state under a little bit of a spotlight, but state building data systems is kind of a complicated task, and we don't always look forward, we often look backwards, and we're very, very conservative in terms of a risk kind of management framework. So as an example of how we're actively dealing with this question right now, I wanted to talk about how we're actually doing an AI project right now. And I want to give credit to Andrew Hill, Lance Lee, and Kason Grady. Andrew Hill in particular in the Division of Water Rights. It goes to the staffing question. How do we find staff and kind of bring them on board and give them the flexibility and the freedom to kind of take some risks? Andrew was a Sea Grant fellow that was working in another division and said, hey, I have this tool that I developed, not me, but Andrew developed, that can automatically identify trash on the street. And it can tell you what kind of trash. And it can tell you if it's a cigarette butt or a bag of chips or all these other things. And we put it on some street sweepers, and you can then identify hot spots of trash generation. You can start to propagate this forward. How would this work for trash management in rivers, putting receptacles and bins in certain places? You can do the soft regulatory approach as opposed to a hard regulatory approach. And so we approached Andrew and said, could you do this for cannabis? And Lance and Kason had already kind of started working on this. So I'll show some slides. This is what a cannabis grow looks like from air photo. You can see the very repeatable, I don't know if you can see the mouse or not. Yeah, you can. This very kind of standardized, repeatable pattern. And those are individual cannabis plants somewhere out in California. But the challenge is, how do you find that one tiny little grow in the state of California? Well, we have access to imagery, NAPE imagery, NAIP. It's a product of the United States Department of Agriculture. They fly the entire United States about every 2 years and then make the data available for free about a year after the fact. Each one of those green kind of dots is a NAPE image. So we'll take a look at a couple of those NAPE images in just a corner of the state of California. Each one of those squares is a NAPE image, right? So the green dot here, the green square here, and each one of those is multiple hundreds of acres in size. And what we used to do was have a staff person scroll through. And each one of those, they kind of look in, zoom out, and try and figure out, is that a cannabis grow or not? And sometimes it's hard to tell, sometimes it's really easy. But what Andrew built, again, working with others, is a tool that will automatically identify that pattern just using a machine learning algorithm. So you feed it the image, and an hour later, it spits out all the identified cannabis cultivation sites for an entire county. It only takes an hour now. It took a long time to get there. A lot of training, a lot of kind of practice, a lot of identification. Not only now can it do the individual cannabis grows, it can do ponds, tanks, greenhouses, all these other things that we've kind of added on to it. So that's, again, a zoom in of just a part of that NAPE image. Here's another example. Those are all the identified cannabis cultivation sites in just this one image. You can zoom in a little bit further, and again, each one of these kind of outlined areas was identified by a computer, and then it is fed directly to a staff person. So a human stays in the loop, because there are sometimes mistakes. Every now and then you'll get something that, we did send one letter to an artichoke grower. Turns out artichokes and cannabis plants look fairly similar to an airplane. But what does this mean? What do we do now that we have this tool? Well, first off, it saves an immense amount of staff time. It used to take us weeks of going through at an individual staff level this kind of data custodian, data janitor role, where there wasn't a lot of excitement for the staff doing it, and it was kind of boring and routine, but you had to do it to take the next step. Now we can do it in an hour, and we can do the entire state over a couple of weeks, and there's some still learning that the algorithm needs to do. It works better in Northern California than it does in Southern California, and it gets into nuances about the cannabis cultivation market in general. A lot of it's moved towards indoor grows and all this other type of kind of nuances. But there's a correlative increase in the development-related work. What do I mean by that? Well, okay, great. We used to spend the time going through the image on our own computer. Now we spend the time procuring the imagery. Now we spend the time managing the data sets of the cannabis or CannaVision kind of output itself. How do we store that data? How do we take those little kind of color-coded circles and translate that into an actionable or implementable task? You have to cross-reference it with addresses. You have to cross-reference it with ownership information. And so the type of work is drastically different. The amount of work has actually increased. And the amount of work that we need people for, skilled people for, has increased as well. And so that's, at its kind of highest level, a policy implication for the entire water board. How are we going to get the right people to do the right work, recognizing that the type of work is going to change, and it's going to change even more in the next couple of months. So we still need just as many staff, but those staff could work on other action outcome-oriented tasks instead of the data custodian tasks itself. And so I kind of flipped the words, this is my last slide, AI in the age of policy, because sometimes you can have the tail wagging the dog a little bit. You can generate data that will drive policy, but you can also have policy that will drive your data generation. And that can be problematic and challenging in multiple ways. And so how do you kind of plan for that or prevent it? We have to realize that we're already being much more efficient than we were just a couple of months or weeks ago. But because of that efficiency, we're going to tee up policy questions far sooner than we ever would have been able to before. So this cannabis question, right? How many cannabis cultivation sites are there in County X? 2 years ago, that would have taken us a couple $1 million in contracts and a couple years to develop. We'd have to go out and find somebody who had this tool and expertise. And it gives us time internally to kind of focus on the question and tee it up to our policymakers and decision makers. Now we know in an hour. So we have to be prepared for pushback. If we push too soon, if we give answers that we're not prepared for, or if we bring policy questions that people aren't aware of or aren't ready for, there will be pushback. And then lastly, the staff workload will not decrease, it will change, and that change is hard. So in addition to kind of just the hiring policies that we're gonna have to think through, it's change management within the division itself, within the entire water board. How do you take a staff person that's been doing something the same way for 10 years and say, you have to think about it differently and do it differently? And that's not just an AI question, it's also for building a new data system as a whole. Those are really challenging things, and it's not something that, at least at the state government level, we're very practiced in. It's going to be challenging for us going forward. So I think that's it.
We talked, it's interesting because you mentioned different kinds of policies, which, you have the policy that comes from the legislative management of AI, you have the policies internal to the agency, and then you have the policies that are impacted or implicated by AI and how we can effectively use it in the policy realm, such as the CannaVision example. What are your favorite examples in policy of some kind that you've seen that you didn't have time to share with the group, like a concrete example of where AI was useful, or policy was helpful, or it was hard to implement? Anything in that policy arena, just to illuminate the issue a little more.
I'll start by not answering your question.
You can do whatever you want as long as you give cool stories from other places.
So a real policy is, because of the unknowns, because it's the wild, wild west of using AI, don't use it at all. And that's a real policy that's out there. And I think that's probably the worst thing you could possibly do. The US as a whole, right, hasn't really come out with an artificial intelligence legislation. It's currently at the state level. But in Europe, in the European Union, they do have the AIA, the Artificial Intelligence Act, that has been working its way through, and it's quite detailed. So if you're interested in that, I would suggest looking that up.
Yeah, I think part of the challenge is, you take a look at, we can go to Europe, You know, the EU has like 46 pages that regulate the manufacture and distribution of cabbage. So you've got the over-regulation on one side, and then the under-regulation on the other. And I think what's going to happen in California, at least I hope from the standpoint, is we need to do two things. We need to get more industry collaboration, and I'm not talking the giant people, the ones we all hear about in the paper, but really a cross-section of companies that do the data analytics, and see how they can use it, and work with the legislature for that. But then I also think we need to sit down as a vertical within policies of water agencies, city councils, trash districts, whatever it might be, and work on their side of it to say, these are the important parts for us. Because I can tell you right now, if you take a look at city councils and the amount of data they have to deal with, it's a different type of data, and I actually don't think it's as voluminous as what we have to deal with. Water's different. Get those conversations going, be it at the data collaborative, be it at other groups that we can work with, and start doing the bottom-up side, because if we do it right, we can meet in the middle, and it'll probably be pretty good. But if it goes one direction or another, then I think it's going to be pretty much a mess, and we'll spend the next 10 years unwrapping it.
Good point.
The AI and ethics question, I think, is huge, and the administration is already working on this. There's an internal, or it's not an internal, it's a multi-agency working group of AI and ethics in California data. The water board staff are involved, and there may be others here who are working on that. And that, I think, is a great start, but it needs to go probably faster and broader than where it is right now.
Do we have any questions from the audience?
My name is Sarah Musiker. I work for Flume Water, which is a private water technology company. We do a lot of work in data, work with a lot of utilities. And one of the things that I really found super interesting was the comment that, or the belief that if utilities don't adopt this, they're going to be left behind. But I'm really curious, we're talking about an industry that, you know, with some notable exceptions, is not exactly known for innovation, no offense. And, you know, the term water buffalo, especially for GMs or water boards, come to mind. These are people that have been in the industry forever. They believe that it works just fine as it is. They're not interested in changing. Forget even knowing that this conversation in this room right now is happening. Like, that's just not part of their MO. And so I'm really curious, how do you manifest change or even start the conversation when the decision makers at the top are not exactly friendly to this future mentality?
It's a big challenge to jump in. When I first got appointed to the board, was just a few years ago. There were people within the local area that had been serving on water boards since I was in elementary school. So, and it is a statement and it's a challenge, because we do need to get more, additional younger people in there. But if you take that one statement, take AI out of it, you're talking that as a challenge within the water industry across everything. There are some agencies that are interested in wastewater management and reclaiming water. There are some who don't care. There's a whole dichotomy of the different decisions that need to go on, and getting everybody to care, 700-800 water agencies to care, is going to be difficult. I think we have the opportunity because, and maybe this helps with the water buffalo comment, because the industry has been along for so long and how they've done things, sometimes that's more difficult to change. But if we have a new capability like AI and we can shape that to make it easier to adopt. So I'm hoping that that's what ends up happening, is because it's a newer technology. I mean, and I love the term democratization. If we can take some of the, pick 5 or 10 solutions that we come up with, real-time water analytics, monitoring, leak detection, some of the easier ones, and we can create solutions that can go to everybody with very little effort, I think that will help drive the change on this part. I can't talk to the other longer-term issues that have been going on with waters for 100 years, but because this is new, this actually may be our opportunity to influence it and get it moving on a faster trajectory, I guess.
What are you seeing?
So many thoughts on that question. So thanks for asking. A bit of validation on your comment about innovation, and some of you may have heard me talk about this before. The water sector is pretty low on the list of sectors that innovate, but we are beating one sector. So there is one sector that we're beating, that's hunting. So we do have a bit of work to do. And you know, one of the observations of technology, AI, things that I've seen is that we like to do pilot testing in the water sector. And I think it's probably fair to say the water sector has more pilots than the airline industry at this point, but we don't actually get past that to actually implement something, right? So I think the lesson learned on that is that if we Well, policy doesn't have to be top down. It can be bottom up, right? And organizations don't innovate, people do. If we wait for the organization to foster the innovation, it's probably gonna be too late. So it all starts with the people that are, I call the frontline operations staff, right, and throughout your organization. So.
Now, I would just add quickly that I think drought and climate change is going to be the great reconciliation of that issue. 6 of the last 9 years have been critical drought years, 22-year mega drought on the Colorado River. We had a great water year this year. That means nothing for next year. And we had a great water year in 2017, followed 3 years later by the worst 3-year drought in recorded history. So there will be more droughts, and those tend to be the issues that force these kind of harder conversations at these higher levels.
Okay, I'd like to make a ask a practical question, because I think Frank's issue about the partnership between the private and the public is absolutely the key here. And so I'll use a metaphor here, but I think the issue that the water industry is facing today is that basically we're looking at things like neural network models, so let me use that metaphor, and we're starting off rather than in a very new system, but we already have Alzheimer's. And the problem here, to me, is silos. If you actually look at the network that we're dealing with here in the water industry, we've got hardware, we've got software, and then we've got the human dimension. The problem's not going to be the hardware and the software, it's the human dimension. And the human dimension problem that I'm seeing, that I have to deal with on a day-to-day basis, is I don't have vendors, I don't have people in the private sector that have a standard, so I can actually extract the data from their sensors or from their equipment that is useful. I don't want their software, I don't want APIs that are barriers to me being able to extract that data and bring it into the system, because in many instances I can't even get at it, and some of their software has flaws, et cetera. So my question is, what is the industry doing now to ensure that all of these private vendors and all these people that folks you're working with are going to be aligned with getting you access to the data that you require to ask the non-trivial questions and solve them?
I'll take a stab.
See me throwing it at
Yeah.
him? No, you do that.
Sure. The kind of most end member response, I'll give 2 responses. The most end member is you set a government standard and you drive it through a regulatory requirement, right? But that's a government agency coming in and saying has to be in this software package and do all these very specific and prescriptive things. The other end member is you kind of say, well, do it however you want. And right now we're, I think, in that do it however you want area. We were talking over the break about metering and measurement requirements that were passed in 2015 by the administration. For the first time in 2015, water rights diverters had to start actually measuring how much they were diverting and reporting that starting in 2018 and 19. And unfortunately, because of the structure of what we did, there are 20,000 Excel files in 6,000 different formats. And so functionally, that data is useless. And that's the kind of no regulation scenario. The other side of the spectrum is being so prescriptive that you then drive a specific brand of equipment and software. And I don't think we want to go quite that far either. In the middle is saying you have to meet a certain formatting standard, and then it is up to the deliverer to deliver that in the standard in the format you require. And I think we can put some time and thought around what that structure looks like, at least in this water rights example. I would hazard that there are other examples as well.
Yeah, and just to dive onto that a little bit, a couple statements. Unique is expensive, unique is exclusionary. So if as somebody in the private sector, if I create a solution where I have to buy somebody's proprietary architecture or their proprietary protocols, as a policymaker, I'll just move on, because SCADA standards are pretty much, they're not rocket science anymore. Moving ones and zeros is pretty easy, and for a couple $1,000, I can get any program to talk to any other program and export the data. So the agency or the companies that will be asking you to sign on to their proprietary network or protocol and stuff like that, I don't think they get to play. I think it's going to move too fast for them. So the second one is how the agencies take a look at it. Now this gets into the dichotomy of the different data sets. Again, we're going to have to take a look at it as policymakers and say, all right, to expose our data to outside analysis, maybe we have to do a little bit, and this kind of gets to my bullet on data cleanup. We may have to do a little bit so that people can talk to our stuff a little bit easier, but I honestly think that those are not difficult problems for private sector companies that would like to participate. For the ones that want to come in and homestead and lock things down and make you buy their architecture, 20 years ago you can get away with it. You can't anymore.
Jim, you want to make a final thought
Sure.
on this before I do my last lightning round?
Very
so we
quick.
get to
So
this panel?
one of my roles is I lead the engineering division for American Water Works Association. And in my experience with that, I've found you can get a small group of very intelligent people to sit down in a room and solve any problem out there, right? It's us, right? It's the culture, the headwinds that we kind of come up with that are truly the roadblocks. It's not technology, it's not process or policy. It's just getting the right people in there. And there's people in this organization, or in the water sector, some are clearly in this room, that say, you know what? We're going to do it differently, and we're going to make it work, right? It's going to be difficult, but that's how you advance. And those people, you're seeing the results of that. You're seeing conversations that we've had so far in the past day and a half on that. So, yeah, go for it.
Great. Well, then to close, I want each of you, again, this is like a sentence answer for each, not longer. What keeps you up at night about AI, and what gives you hope? So we leave them with hope.
Cannabis.
Cannabis.
Mr. Cannabis.
For everything, right?
Both answers.
He is not the deputy director for cannabis,
Yeah,
I'm just saying.
The panel on dreams earlier was interesting because in no world did I ever dream I would spend so much time thinking or talking about cannabis. No, but I think that is the answer, right? Like just that one experience shows what's possible, shows the challenges at the same time.
On the possibility side, I think this is such a great opportunity for our industry to do an inflection and help our employees get away from what they've been doing forever and get them to higher levels of their personal satisfaction with their careers. I think it's going to be a great opportunity because they're going to be the ones driving it. What keeps me up at night is actually what keeps me up at night also is cybersecurity. If we don't have enough control on the systems that we have out there and we have somebody who goes renegade, oh, I'm sorry, it's one sentence.
Go
I
ahead.
apologize.
Keep going.
I blew that one. But it's us losing the control over those systems and have some of them go in areas that they shouldn't be at, tripling the fluoride or opening floodgates and doing whatever and letting water out. Those are the things that worry me is when we lose control, especially of the SCADA systems that we currently have.
Okay, you exceeded your parameters, but that was still fine.
What keeps me up at night? Where we are in maturity of analytics and AI in the water sector is that AI is all about the hype. It's all about the marketing today, and it's almost way too much to that level, right? We're over-promising and under-delivering because that's just where we are in our maturity, right? And from the vendor side, right, it's a bit of an arms race to say who has better AI. From the utility side, we don't have the experience to know to ask the right questions to that, and it's concerning. On the hope side.
Oh, good, you're going to end on hope.
So it's such an amazing time to be in the water sector, right? Get past the marketing, get past the trying to take these shiny objects and put a square peg in a round hole, and we can answer questions that we couldn't even conceive about answering in the past. When we actually embrace some of the technology, when we start to look at digital twins, we start to look at these things and say, okay, let's answer some of the very simple problems we have in new ways and new technology, like looking at cannabis, right? I mean, such a simple concept, simple actually technology, very easy to do that. You can really change how we do things. So it's amazing. We're only scratching the surface. So.
That's true. Well, thank you. That's a fitting close. And join me in thanking this panel. Hopefully they'll be around during lunch and over the next months and years.